Hello. Sorry. We good now? Okay, that must have waken you up. That was intentional? No, not. It's not intentional. But at least it caught everybody's attention. Good afternoon. Or Sabaidi? Oh, Sawadika. Sorry, I was in Lao just the other day. So every day I was saying Sabaidi. So here's Sawadika. Um, this is the network monitoring and management tutorial. So if you are here, we'd like this session to be more of a hands-on workshop style. So if you have your laptops with you, please bring them out. We will follow a program. Sorry if we started a bit late, but we're supposed to start at 2 o'clock and hopefully finish up around 5 p.m. this afternoon. So we may need to squeeze in quite a number of things during the time that is allocated, but hopefully still enough time for you to have some hands-on experience. So how we're going to do this is, if you can access academy.apnic.net and find this event, you will see the time schedule and information about today's activity. So I am a bit optimistic about our session, but do let me know, because usually I try to get everybody's knowledge level at the beginning of the class to see whether we need to provide a bit more in-depth or foundational discussions or concepts, or we can quickly run through them and focus on, more advanced and more hands-on. So what I am planning to cover is the following. We have about a little over an hour now for the first session, and I would like to cover an introduction to NMM for sure. We need to have that baseline understanding for everybody to set the mindset, to have that thinking on what is the importance of network monitoring and network management, and what does that exactly mean, right? I think most of us do have some idea coming into this session. So we will build up on that. And then following, we will talk about two time series database tools. One is initially looking at the baseline, which is SNMP, which I hope, again, most of you do have some background. So we will just brush through this if possible, or we can go into details if you want to, and then focus on RRD tool. More specifically, we want to use LibreNMS. So we have here a lab to set up, configure a server with LibreNMS, and a couple of routers or network devices that will connect to it. That is running on a virtual lab that we have also in the system. So this requires that you log in to the APNIC Academy to open or launch the lab. So I would encourage you now, if you can and you don't have an account yet, to please create an account on this page, so that when it's time to launch the lab, we can do that very quickly. All right. The other part, I'll go into session 2, which I am planning to maybe do during, after we finish the break, is time series database. Time series database, obviously RRD is an example of TSDB, but this one focusing on a bit more modern way of implementing them, particularly using things like InfluxDB, TIG, Telegraph, and Grafana. So we have a TIG lab as part of session 2. However, given the time, let's see how we go. Maybe it will be a hands-on for you guys, or perhaps we can run it through together, which means it will be more like a demo that we can run quickly during session 2. What do you think of this session? The plan, hopefully, is good for everybody. All right, again, the link to that is in academy.apnic.net. Please feel free to grab the materials that is downloadable from there, and also the links to other resources, as well as the labs that we will be doing later today. Now, I'll do a very quick rundown of what we plan. Obviously, I've already shared the resources, the course materials, all the slides, lab materials, and links to the survey will be available from this link. So please have a look. Next one, quick introduction. Hopefully some of you know me or have met me. If not, please feel free to have a chat with me during breaks. My name is Shane Hermoso. I am from APNIC. APNIC, as you know, is the Asia Pacific Network Information Center, and our main goal as a registry is to distribute IP addresses and other resources to the region. I am part of the training delivery team. So I've been mostly a trainer for the past 10 years. And obviously, I am also a network engineer. I run a lot of systems, mostly enterprise networks. I do DNS, I do network monitoring, I do all that, all that stuff. Anyway, that's me. And this is the course outline, which we've already seen earlier. Now, just a very quick, maybe run through APNIC Academy. This is the page that you're looking into to access the page and the events link. But we also offer a lot of things in the Academy. So I'd like to take this opportunity quickly to encourage you to have a look at the resources that are available there. The labs that we are using today is actually available at any time to access, free for you to use. So whether we manage to complete the labs today or not, you can still come back and access that through the links here. At the same time, we run regular online tutorials, online labs, and webinars that you can also join. All of it, usually, if it's online, is provided for free. APNIC does policy development process. For some of you may be familiar. That's how a lot of the policies that we implement are actually developed with the help of the community. So, I hope you actively participate in the policy development process. And finally, again, a very quick plug, APNIC 58 is coming. It's going to be happening in New Zealand this year. As you know, the earlier one for the year in February actually happened here in Bangkok. So we were just here 2 months ago. The next one will be in Wellington. The fellowship for this one obviously has already closed, but I do encourage you to apply for APNIC fellowship for the next one. It's a good opportunity to attend these events. So your airfare, all of that will be covered for you to attend either the workshop or the conference. So watch out for the next one when it happens. So I'll leave it there. Have a look at that page. But what I'm going to do now is start the first session, which is an introduction to NMM. By the way, we'd like to obviously thank BKNIC's Spring Forum and ThaiNOG for the opportunity for us to do this session with you guys. So it's always fun to be here delivering a session. For those who find that I speak a bit fast, please just stop me at any time and tell me to explain slowly and repeat again if needed. Our goal at the end of this is to learn something. So make sure that you take at least one thing, whether it's just knowing that, oh, there is LibreNMS, there's open source tools that I can use for NMM, or just understanding the concept of what needs to be monitored and how it will help your network. All right, so take something from this workshop. So, all right, this is what we're gonna cover for this session. Well, first of all, what is network monitoring, right? I think, as I've said earlier, we do have some knowledge coming here. We want to monitor devices. We want to monitor our network. We want to be able to know what is our network baseline so that we can act accordingly. How many in this room are network administrators, network engineers, systems admins? Okay, quite a few. Not everyone. I'm surprised. We have students in the room? Do we have any students in the room? We have bosses in the room? What are the others? So, but for those who have been managing networks for quite some time, you do know that having that sort of visibility helps us to know what to do in case of downtime. We know what to do and where to start troubleshooting if the capacity has gone up significantly, if our traffic is suddenly very high. But thing is, how do we know that it's high or it's low or it's normal or it's not normal, right? That starts with having a knowledge of, first and foremost, what's here? What's in my network? What are we monitoring, right? In the past, networks are very simple. These days, it has become more and more complex. We're not only monitoring devices that are usually within our local network, we're actually monitoring a lot of services, whether maybe it's something that we manage altogether, or it's a service that we're paying for over the cloud, over the internet, from other, service providers. And in some ways, we want, again, to have visibility over those. So from being a flat network, we now have to run or know about complex networks in the cloud, remote or local, mobile devices, IoT devices, connected locally or connected via remote, all of that. So while simple networks don't require or don't meet the simple networks are very simple to manage, but nowadays we run more complex networks that is what we call modern infrastructure that runs services that we need to be aware of. Therefore, we probably need to have a plan. We need to have a strategy on how we have to monitor them. So in spite of all the evolution that has occurred, one factor that has been constant before, when I was young and we only managed a local network, and nowadays we need to do more, there has always been a need for network monitoring. And obviously, we need to understand which devices, which network components, which protocols are running on top of those network devices, and what are the available tools. So we've listed down a few here, okay, some of the common ones. But this may be something that you have or something that you probably don't. At the end of the day, each network is unique. And so we need to kind of have an understanding of your own network. We are looking at two things here in this class. It's network monitoring and network management. Is there a difference between that? We usually combine them together in some ways, but there is some subtle differences, obviously, between them. With monitoring, the focus is to have a constant way of checking or scanning the status of our network, collect different statistics, different metrics for performance, etc., so that we can see whether there is an error, whether there is an alert that will then be known to the administrator, okay, the network admin or the sysadmin that is now responsible for fixing, the issue. So this one's pretty straightforward, right? The idea of it. But exactly what does that involve? Well, we're looking for, or we should know what we're looking for exactly. Is it throughput? Network throughput? Is it the network latency? If our client is complaining about the network is slow, I can't load this page, these are some things that we can look at. Are they, is the problem on our end? Is the problem somewhere else? Is the problem being seen by multiple clients, multiple subscribers? And does my monitoring tool confirm that? Sometimes we think, oh, it's just this client. Maybe it's just them. But maybe there's actually an underlying reason. And through this, we can have some way of confirming it, right? So latency, packet loss, bandwidth are some of the things that we monitor or look for, but there may be more. How do we find it? Different tools are available, SNMP being one of them, but we can also rely on APIs. We can rely on simple ping to know that something is up or down, particularly for interfaces on the network. And there's many others, right? Now, where and how do we store the information that we get? Depending on how large our network, it will always give us lots of data. Logs that we store in maybe a central server. The server can be stored locally. Maybe different servers will have its own, but you can also pull all of that into a centralized repo, a centralized database, like Logstash, for example. Or it can be somewhere in the cloud. We will be talking about RD and time series data, so that's the focus of today. And what thresholds indicate a problem? Obviously, that's performance matrix. And lastly, who do we notify? And how do we notify them? What are the available means to exfiltrate these information or these alerts and contact the relevant administrator, a relevant party, and what are those available means? Is it via email? Is it via SMS? Is it via webhooks, system alerts, etc.? So that's for monitoring. Management now focuses more on processes, tools, and applications to operate and maintain a network infrastructure. This kind of sounds a bit too broad, right? But essentially, you want to be able to manage network and network devices, servers, and applications so that we know when or how to add more capacity so that we can configure them maybe in a more automated version so that we know that if there are changes in those configurations. So that's part of management. It involves different different means or different parts, such as provisioning. That's what I talked about. If you're expecting your network traffic to grow in the next 2 years, and say, for example, you are at a certain bandwidth, 60, 70%, and you've seen that growth over the years, you can project that maybe next year, I need to double my capacity, right? That's part of provisioning. Or as simple as spinning up new VMs, new virtual machines, so that you can share a load on a service. We also have maintenance, which means upgrading and fixing network resources. This is a normal day-to-day job for a network systems engineer. We usually schedule maintenance periods early in the morning or very late at night when the system is not used as much. But what is it used for? Well, essentially, if there are upgrades, you know that there's a new version, there's a security patch, you need to apply those patches. So that is part of management. The next one is the typical operations. This is the baseline. This is the expected way that my network is operating, and it's working. It's working pretty well, right? There is no downtime. There's no outage. Outage usually affects users, affects our clients or subscribers, so we need to be aware of that. And lastly, more on the administration side of things, to be able to track what exactly is running on your network. You know that I have a legacy Windows 98 server somewhere in my network that is still being used. Sometimes I go to networks where they actually still use some of those very old systems, but they don't know it was still up. That can potentially become a security loophole, right? So having a knowledge or tracking of what network devices, services, everything runs in your network is very important. So as I said earlier, every network is different. Therefore, no single system will solve all your problems. What we can do is provide you information on what's available out there and what is typically being done by majority of folks, and make sure that based on your requirements, you utilize those tools that are available, to meet them. Okay, any questions so far? We'll go a little bit deeper into network monitoring, the why, the how, and the what of network monitoring. First off, why do we monitor? Okay, again, I think lots of this are probably known to us already. We want to be able to track resources, and this works for time series data. We want to be able to get a historical data, historical information over the years. What has changed? What it is now compared to maybe just a month ago or maybe a few years ago. So you should be able to track in time, going back, and know, what is the status, what is the state of this device at that point comparing to now. We want to be able to establish a baseline. For me, this is more like, vital signs, especially for us, for health. You have vital signs. Your heart rhythm, your temperature, and what is normal. It's the same thing with network. You have vital signs. You know that the normal for this network is this many number of enterprise users connecting via VPN to my network from 8 a.m. to 5 p.m. Not so much after hours. So if there is someone who did try to attempt to connect to your network at 1 or 2 a.m., it will trigger an alert. It can be knowing that your typical bandwidth is maybe, less than 50 Gbps on a normal day, except when there is like an update. There's an iPhone update or an Android update or an OS update, and then your traffic will spike. So you kind of can pinpoint what is happening that will have an impact to those changes. But outside of that normal, you will think, what really is happening here? Is there an attack? Is there something going on? And that will trigger network admins to start investigating. Maybe there is nothing wrong. Maybe it just so happened that someone is downloading a huge file, but maybe there is something wrong. And therefore, it allows you to investigate and potentially avoid having to answer for a downtime or a security attack. Next up, understanding the performance metrics, performance matrices, and do capacity planning helps us to identify possible issues before they affect business continuity. This works obviously for every network, but more so if there is a lot in line. If a lot of your services, for example, are available online, and a short downtime will cause a loss, monetary loss for your company. These days, I think on average, it will depend, obviously, for countries, for economies, for what type of services you're offering. But some studies say that on average, a typical loss for 1 hour of downtime is at, I think, close to 30,000 US dollars, which is a lot. I'm guessing they have like really high earners in that study, but that is really high. So that will affect business continuity. So we want to avoid that. So we want to also find the root cause of the problems when something goes wrong, track config changes, as I said. And this is usually the first step in identifying security threats. So logging, monitoring is always an important aspect, an important part of security monitoring, right? So sometimes in bigger companies, you have a separate SOC team and a separate NOC team, but they work really closely together. For the SOC team, it's getting all of that logs, all of that information together in something meaningful to see that if there is an IOC or an indicator of compromise. But it all starts there, having proper logging, having proper monitoring. So this is what we're monitoring. Again, everything, hardware, services, applications, whether it's on-prem or on the cloud, making sure that we know which services are running on all servers, and make sure that those that are not used, we actually turn it off. Sometimes when we install, there are default ports that are open, there are default applications that are installed. It is up to us to set what is really needed and maybe set a template so that when we spin up a new container, a new VM, we only have a minimal install, what we actually require, okay? The question is, do we monitor everything or do we monitor just critical services? I don't exactly know the answer to this because the answer relies on, your own implementation. But as a general rule, it's always okay to monitor all resources, so long as it doesn't overwrite or kind of like your attention diminishes on the critical services. Maybe it means that the number of times you monitor like less important or less critical services will be only within 30-minute intervals instead of every minute. Most critical services needs to be monitored maybe even every few seconds, every few minutes, every 5 seconds, every 5 minutes, etc. It's up to you. But again, I think it pays to have some monitoring available for all resources. Next up is, do you only monitor the underlay network, which is, your layer 3, your BGP, your OSPF, your routing, all of that, which is your underlay? Or does it pay to also monitor your overlay networks, your OMP, your VXLAN, EVPN, all of that? Well, it's both, right? Because your overlay networks rely very heavily on the underlay networks. At the end of it, whichever you monitor, you need to look at availability, the uptime of the system, reliability, capacity, and performance. Okay? So how do we monitor them? We've talked a little bit about these technologies earlier. So listing them down here again. Ping, SNMP, syslog, CDP or LLDP, NetFlow API are just some of the tools that are available. There can be more. Okay, we need to be able to leverage these available tools, okay, and make sure that the tools that we use, the monitoring tools or monitoring systems that we have, actually have support for majority of these technologies. Now for network management, again, looking at the how, the why, and the what over this. Why do we manage? What is it used for? Again, it's for maximum efficiency and to improve the productivity of your IT systems. We want to maximize the resources that are available to us. Security and threat detection is another one, to be able to see whether there's security loopholes in all of them, and to aid in network upgrades and visibility. What do we manage? Most of these, again, all the devices that are connected to our network, and not just network devices, not just systems, but potentially even power systems, your CPEs, storage devices, and maybe, a lot more. How do we manage them? So you will notice that in a lot of, even for monitoring, most of them are using agents and kind of like a server or a manager. So agent manager setup. So we kind of use that, right? Agent-based means that we reside on, we have an agent residing on or installed on a system or the device that is using, or that basically that we want to monitor, right? The most common protocol here is still SNMP, SNMP set, and then SNMP get, and all that. But there are more and more devices that have support for things like netconf and restconf. So see here a comparison between SNMP, netconf, SOAP, and restconf. I think most of us, hopefully, are quite familiar with SNMP here, which takes advantage of what we call as OIDs. So there is a way that we identify system uptime, interface uptime, or interface availability, whether they're up or down. So all of that information defined by OIDs, and we can pull those information, okay, using a network or SNMP manager. So a very quick rundown of network management and monitoring best practices. This is kind of like a summary of what I've talked about already. So having a baseline network behavior or understanding what is the baseline of your network is important. Next to that is, of course, having an escalation point. It doesn't matter that you have an alerting system when it doesn't actually alert anyone. Or if it does alert your level 1 support, for example, if they are not capable of solving the problem in a timely manner that it doesn't impact your business or your service. So knowing who to escalate them, who are the contacts, and maybe automating it. So how many of you have on-call? So having an on-call person is quite normal for operating networks. Some of them, they give that responsibility to another party. Some of them are running it in-house. But then if it gets to a certain level that it needs to be escalated, usually it's a contact person that you can call, even if it's like 1 or 2 a.m. in the morning, to solve it. In our case, there are also application that does this automatically. It brings the level 1 support, and if he wants to escalate, escalate that in the application, then it automatically escalates them, calls or triggers alert on the second level, third level, until someone, answers it and then solves the problem. Okay, that's quite normal these days. Layering the layered breakdowns. Essentially, kind of, this is more about knowing or segregating your network or your infrastructure and knowing who is responsible for each, knowing who can solve, or fix issues for each one. You have a different VoIP person to answer more or to solve any voice-related issues. You have a web guy who does all the website-related stuff. You have a network guy. So knowing who will be the right contact point, will make resolutions a lot faster. How about implementing high availability with failover options? This is something we need to think of a lot more than we're actually doing. If the network is down, and if you're running all of your network monitoring, triggering alert systems in the same network or in the same infrastructure, what happens is you don't get alerted at the end of the day because it's down. There's no way for messages to reach you. So having a way for your monitoring system to have a failover, maybe in maybe cloud-based setup or anywhere. So you have redundancy, you have high availability when when failures happen, right? And then lastly is it helps obviously for capacity planning and growth. So we need to also look at doing the same for our NMM system. Okay. I always get questions about running, let's say Libre NMS in this case. How many devices can I actually add into this before it will cause issues, resource issues, etc. Right? One solution to that is don't let it reach its max point. Have a distributed system. Have maybe layer your network in such a way that one instance monitors only a part of your network or they're a type of device, etc. So knowing how to kind of like plan your monitoring in such a way that it fits your structure and how it is intended to grow in the future is also important. OOB, are you all familiar with out-of-band management? It's always useful. I don't know if you've heard of, big downtimes for large providers, maybe just in the last 2 or 3 years, where the problem was actually related to OOB. I won't name it in here, but essentially, OOB has been around for some time, right? It's something that we set up even for small networks. It's something that we should have for large networks. It allows us to connect to our system kind of like out of the usual uplinks, out of the usual way that you access those, that is available only to us network administrators mostly, so that we can access essential services to fix them as needed. All right, so techniques and tools, we have combination sometimes of these, but it's a matter of knowing whether you're running agent-based or agentless monitoring. Are you running internal monitoring or external monitoring? Or maybe it requires a combination of both, or whether it will be centralized or decentralized. Again, it can also be a combination of those. So it's about the strategy that you implement. More and more these days, we're relying on SaaS-based monitoring and management tools, cloud-based. We are paying for like services over the cloud that monitors our network mostly from external point of views, right? So it's a type of external monitoring. Usually some of them also have option to install something on-prem. So it can also provide you internal view of your system for monitoring them. And these are some of the examples that are available out there. Now here is a list of open source network monitoring and management tools. This is not complete by any means, but a good way of just listing down and maybe checking, am I using this? Am I not using this? What am I using now? And maybe that can be solved by that better. So you can have a bit of comparison on what is out there. Obviously, a lot of SNMP related ones are up here. Isinga, Nagios, Libre NMS, Zabbix. SmokePing is quite old, but it's still very much in use in a lot of networks. NFSend and NFDump. We have here for backup and monitoring. Usually I use it for configuration management or config backups. Rancid and Oxidize, Rancid being the older one and has been around for quite some time. We have logging, log management, syslog, graylog, and all of that. And then quite a few others, I think, that you can find. We'll talk about a couple of others here as we go through today's session. All right, so what next? What we're going to focus on for today is these two. So as I said earlier, SNMP has been, a known way or a known means of doing network monitoring and management. We use SNMP get and SNMP trap for network monitoring and SNMP set for network management. Whereas we have available modern tools, which includes time series database, model-driven programmability or telemetry, such as gRPC, APIs, webhooks, kind of like everything can be accessed via API these days. And for network management, we have netconf, resconf, openconfig, where sometimes there's quite like, a preference from folks whether to use netconf, resconf, or openconfig. I feel like these days we're kind of settling on one of those options, but the rest are still out there. It's still available. And that's what we are going to cover more. Any questions so far? This is more of like a higher level overview of network monitoring and management. Hopefully set some ideas on, what it requires. Still on a high level, obviously, but we will focus on a bit more detail as we go through. Any questions? Anyone running any of the NMM tools in your own setup, in your own network, and what is it? You do use any? No? How about you? Using any NMM tools? LibreNMS. All right. Yep. I think this is from personal experience, but I think 4 out of 5 every single time I would have 80% of people using LibreNMS out of everyone that I talk to. So I think it's very popular. Any others? How many of you are using any NMM tools? Using any? No? No, not yet? Zabbix, still on Zabbix. All right. Cool. How about you guys? MMIX. LibreNMS. Still using Zabbix. How about for config management? Not yet? Excel? Legacy way. That's legacy way. All right. So we move on to the next one, which is a very quick, hopefully, a quick introduction to SNMP for those who needed that. Where is it? There you go. For anyone who needs that refresher. So a review for others, maybe something a bit newer for others. But it's not just SNMP on this slide deck, but we'll talk about RRD tools and then move on into LibreNMS. And then by that time, hopefully, we can do a bit of labs. So SNMP is Simple Network Management Protocol. Why is it called simple? This, by the way, has been developed in the early 90s. So we've gone through many iterations now. SNMP V1, V2, which is also V2C, and then V3. V3 technically being the secure version of SNMP, but a large number of applications actually still do support SNMP V2C and has not updated that. So V2C or V3, all good. But what is it? It's an application layer protocol for managing and monitoring network. It's simple because it only has a few messages or a few functions. You get bulk, you set, things like that. So it's very simple. You run an agent, you run a manager, and they connect with each other with a request and response type of exchange. So what it does is to detect issues and any faults early, monitor your device, and if you can, use the system to remotely configure and control, because you can set values, you can change or modify values, you can bring a network up or down, etc. It's a simple protocol using UDP port 161. So these are the components. You have a manager, an agent, an MIB, and obviously you need the device that the agent is usually installed on. All right? So anybody here not familiar with SNMP? No? Okay, let's skip this. Nah. Let's go through this very, very quickly then. SNMP manager is obviously the one that collects all the information, all the data from devices that you want to manage. The polling will happen via UDP port 161, and usually you have a central software application that does this management. So if you have an NMS, it is something that you would consider as an SNMP manager. That's it. An SNMP agent is usually a process that runs on a device. So these days, majority of these devices has some type of SNMP agent already part of the device. So you don't really need to install anything. I think most routers, most servers do have support for SNMP as part of their operating system. So what happens basically is you have your agent is here, you have your manager here. The manager will usually query or request certain data from your agent, and then the agent will respond to the SNMP manager. That's it, right? So request and response. But there's also an option for the agent to send what we call as trap messages, which is unsolicited messages sent to your NMS server if there is an error or anything really that is out of the ordinary. It will send an SNMP trap. Okay. So aside from responses to query, it also has that option to send SNMP traps. The third component is your MIB, so Management Information Base. So think of it as a database or kind of like a structure, which is a collection of different definitions. These definitions have values. So depending on the device, depending on the vendor, some of the contents of your MIB may differ. But the thing is, most of this structure will have what we call as MIB2, which has a lot of the information that will usually pull that is related to uptime and things like that that we use. How many of you are familiar with this? So that's your MIB structure. You have the root. This is ISO, org, DAD, Internet Management, MIB2 system, etc. So the way that we identify a certain definition is by OIDs, or the object IDs, object identifier. So for example, if you want to find the system description of that device, then it's this one, right? You basically have to say that is .1, .3, .6, .1, .2, .1, .1, .1, which is this one. .0 here because you have another one .0 there, which is because you only have one value here, so only .0. So that's a way of finding those information. So your manager, SNMP manager, should know what OID to query if they want specific information, right? But if you want to just get a series of information, you can also do a bulk query or a bulk get or get next, which I may have the information on those messages somewhere here. Now, I've mentioned earlier that all of the agents would have to support MIB2, which is RFC 1213, which is mostly about TCP/IP management information for anything network. And that is MIB. There are proprietary MIBs. You can look it up. I actually have links to some of these MIBs in the Academy page. So if you want to have a look at that quickly, please feel free to do so. Where is it? Oops. 1 second. Where am I? There we go. So we have here this one, online MIB browser, or this OID info. For those who are not familiar with this, please feel free to have a look. You can use this to kind of try to understand the structure, try to find specific OIDs that you may be interested to monitor and things like that. I don't have the link to the Juniper or Cisco ones here. I would usually have them, but those are examples of proprietary OIDs. All right. Where am I? I think I should be somewhere here. Any questions so far? So yeah, this is the ones, Cisco or Juniper example. I think if you can click in any one of those, it should open up the MIB Navigator, MIB Explorer for either one of them. And you can search for specific data, specific information. It's loading up. Maybe we can look it up again a little bit later on, but that's an example of an MIB. All right, so last one, of course, is your managed device, the one that you're monitoring. We said usually that you have an agent running on those managed devices, but in some cases, if there is no way to run an agent or it doesn't have support, then sometimes you rely on what is exposed. Maybe it's an API, maybe it's an available port, maybe it's a running service that you can query. So you end up having to run like an SNMP agent outside of that, kind of like either in the manager itself or somewhere else, but not entirely as part of the managed device. So these are the protocol commands, right? So this is one of the reasons we call it simple, because you only have 1, 2, 3, 4, 5, 6, 7. So get if you have a specific OID, get next if you want, because you don't want to specify, if it's already sequential, you don't want to specify the OID every single time. So you can run a get next command to just get the next one after the last OID that you have queried, right? So it's quite useful in that sense that you don't have to be too specific on what you are querying. The set command is for setting values for that OID. Get bulk is if you're requesting for multiple OIDs. So you run this command in bulk, and then the response is the response from the client to the SNMP manager. Trap is also from the client, and then the inform is from the manager back to the agent or to the client as a form of acknowledgement. All right, so that those are the only messages that we are expecting out of SNMP. So that's how typically the message exchange between them happens. You have your NMS, you have your SNMP agent, you do a get request, and then response coming back from the agent with the information that has been requested. Get next request, right? That's a get next command, and then it will still provide a response because the agent knows what was the previous OID that has been requested. The trap and inform, as I said, is going this way as an unsolicited message coming from the SNMP agent. So we've talked a little bit about the versions earlier, V1, V2, V3. No need to dive very deeply into it. SNMP V1, just don't use it, please. That's it. Because it passes community strings via clear text. So it's not secure at all. So no one should use this anymore, please. Next one is an SNMP V2, which now have some form of authentication. So that community string is, it's basically a more secure way of passing community strings. We call it V2C at that time because it's kind of like the interim solution once while they're developing SNMP V3. But obviously it has stayed on. A lot of the networks still provide support for V2 or V2C, although you have now option to use SNMP v3. All right. One thing you should get out of this is these community names. So you can actually have multiple communities, one for read only, another with write permissions, and another for traps. So when we say community here, it's basically just a password. So I'm setting a community value. This is exactly the password that will be used to then authenticate, the query or the request between the agent and the server. So what are we providing with SNMP v3 is an additional security, confidentiality through encryption, authentication, and access control. But you have the option. You can say that I don't want any of that, so you use no auth, no priv, or you can have authentication only, no encryption, or you can have both. So in that sense, if you want no auth, no priv, you can set a username. You don't necessarily have to set a password. If you're more into providing authentication, obviously, authentication here is yes, no encryption. So you provide username, you provide a password, or you can do auth priv, which has pretty much all of those options. All right. This is an example of a packet capture using SNMP Walk, which you can install and run on a typical Linux machine. So here we did SNMP Walk using version 2C, and this is the community string. And we can query this agent, and you will see that you have gotten responses from it. SNMP Walk pretty much queries for every OID. So you get a lot, see all of these responses, and you have multiple OIDs here. So not just a single response, because you're doing it sequentially using SNMP Walk. Here is a very quick example on configuring SNMP with one with write access and this one with only read-only access. So this is the command that you use essentially for a Cisco device. Setting up SNMP server, community, this is the password or the community value. And we set that to read-write because of the read-write access. We are applying that on an access list 66, which is your SNMP server. Okay, that's it. And the difference here is obviously we change this one to RO or read-only. And here is an example of SNMP v3. Notice here the options, whether you're using privacy, authentication, etc. And you have to provide the values or the passwords for it if you want to enable it. Here we have a username. User is APNIC, group APNIC, and then this is the authentication, and then the password for encryption. Simple? Questions? Sorry, let me just quickly check. I'm assuming that like SNMP is something that most of us are aware of already. So if not, if you want me to explain further, let me know. Or too shy, I think. All right, we have limited time, obviously, but if you want to talk to me more about those topics, let me know, and we can run through the OIDs, show you the graphs, show you the structure, and do some SNMP queries. It's actually quite fun. I find it really interesting. By the way, in the lab that we're running, in NMM lab, the first part of that is SNMP, which we are skipping for now, but you can run it on your own time, which runs some of the commands that we have shown you here. All right, now on to RRD, or Round Robin Database. So why is it called RRD? It's a type of circular database, which is fixed size, which means that if I only have 1,000 slot in my database and I completely fill it, all right, kind of like you're stacking something, right? You have, let's say, only have up to 100, up to my height, up to 100. So you put the first one, the second value, third value, etc., until you reach 1,000. Once you've completely filled it, what happens? The last one will be discarded. Sorry, not the last one. The first one that you put in there will be discarded. So it's going, and then you're stacking on top. You remove the one at the very bottom and then stack the one on top. So the advantage there is you know the size of your database. When you say RD in this case, usually it's kind of like a file. It's not like your typical database. So typically you will have multiple RD files. And you see that when you run things like LibreNMS or SmokePing or Nagios, you actually have a folder that has these RRDs. So it has a fixed size. When you add new data, it removes the oldest, and then you consolidate data points and you run it in different time intervals. It's up to you what to set there. It can be 10, 30 seconds, 1 minute, 5 minutes. So it looks at time series data, meaning time-sensitive information. And as you know, logs, what happens or what is the current value of, CPU usage, CPU or temperature or whatever at this time period, whether this next minute, whether this the next minute after that. So that is part of your time series. And that is stored in your round robin archive or the RRA, right? So that's it. That's how it actually works. As I said, it's an example of a time series data. The more modern ways of this we will be showing a bit later on, but essentially it's, going back, it is optimized for time-stamped or time series data because it can pull the information much faster because it's optimized for it. So it's actually better than typical relational databases. Okay. So more specifically for RD tool, it is used by popular programs like Cacti, which is a bit older now, but actually that's how I started with this. SmokePing, MRTG, LibreNMS, which you guys are using, and a few others that are based on this. RD tool uses SNMP for data collection. So we're relying on SNMP agent, SNMP server. The SNMP server will also have RD tool to be able to then add the data or that is collected via SNMP into the archive, and then there's a way to process that and show it in a graph format, which is very useful for network engineers and systems engineers. Now, a few terminologies, we'll look at them at an example later on. First is your DS or the data source, where it's coming from, where you're getting your data from, and what are those parameters. Sometimes we call it as the PDP or the primary data point. The next one is the heartbeat. So, like in heartbeat, it beats every how many seconds or how many milliseconds. So you are getting the information or the state at that heartbeat. This time, in the next 15 seconds, that is your heartbeat. Data source type, we have a few, but essentially there's a minor differences between them. You find that you use counter if it's information that like increases over time. Use absolute if you want to kind of like make it zero it out after you've pulled the information. And then there are a few other options as well. RRA, I've shown you in the previous slide, is the archive or round robin archive. And then we have a consolidated function or CF, which specifies the what will be the average, minimum, maximum, or last value for this. Now, the best way to really understand these terminologies is to look at some examples. So let's look at one example after this. This is one way to maybe test it out. Install RRD tool on a Linux machine. So this one is the very simple command that we use for installing a package. So we'll use apt-get or apt-install RRD tool on your Linux box, and we will be able to run RRD tool from the command line. Okay, so here's an example. to create an RD database file. So this is a manual way. When you run an NMS, usually you will leave all of this to the NMS. You'll have a nice user interface to maybe customize what you want, but most of it is done by the NMS. But if you just want to test it out yourselves, obviously you have the RD tool command, and then you can create your RD file. This is just a file name. It will be stored wherever you want to, usually where you run the command itself, but you can specify a different location as well. And then you have a minus step, 900. So 900 is your step value. What is DS again? DS is data source. Okay, our data source, we'll call it as packets. Okay, the DS type is absolute. And then here we have some values. The way to really understand this is to look at the documentation. So let's look at, let me just do that and then skip that for now. We can look at RD tool. Here's a page. Oops, I think I need to change it to English. Fine. So if you look at the documentation here, you actually have just the RD tool command, or you can look at the specific command for creation, which is RD create. It's exactly the same thing. If you use RD tool here, it will really just link you back to that basically that tool. Let's say for creation, this is also RD create. So let's look at this just very quickly. So this is the format or the syntax. What we're after now is this part, right? So the DS, and then you see in here, where is it? Maybe I'll move this one. Oops, now it closed. Wait. Okay, so let me put this one here so that we can still see it. Actually, we have some notes there, so you know that as well, but like make it bigger. So this is what we have, right? So DS and then packets and absolute. So if you look at the DS format somewhere at the bottom here, this is the DS name, and then some information about the DS name, and then you have the DSD, and then DSD arguments. So the absolute here is the DS type. These are the different values that you can have: absolute counter, decounter, derive, etc. So most of the time I will see absolute and counter, not so much of the others. Once in a while, maybe compute. And then you have here, sorry, that's the RA. This one is the timing, basically some parameters. All right, let me just go back up here quickly again. If we can find it. I think it's under DST arguments. Yep, sorry, somewhere down. I can't find it here. Maybe guys have a look first, but essentially this should be your heartbeat. 900 is the heartbeat. Oops. Oh. Why is it loading something else? Here you go, this one. This one is the heartbeat. This is the minimum and maximum values that you can have for that. And then this one is your round robin archives. Notice that for each RD file, you can actually have multiple RAs. So the first one is using X file of 0.5, and then the step here is 1. and then 9600 values. There is an explanation here somewhere that shows what that is. But just for you, so you know, this is the format. So the value here is actually the X files format, I think it's what it's called. And then the steps and the number of rows, meaning that you can have 9600 rows or 9600 values out of that. So what it means for us is like this. As I said, you can have multiple archives or RAs in your RD file. In this case, we have 3. The first measurement is this one, which means you only have 1 step or 1 measurement. Here we have 4 measurements, and this one has 24. What was the heartbeat value earlier? Heartbeat is 900. What is 900? It's 900 seconds, which is what? 300 is 5 minutes, so 900 is 15 minutes. Okay, so the 15 minutes is based on this value. So what we mean when we create this array is that we can have 9600 values. We have 9600 slots of 15-minute periods, which will give you 100 days. If you have 4 here, that's 4 times 15 minutes. So you're actually, pulling the information every hour, and you can have 9600 values, 1 hour each, which gives you 400 days, a little more than a year. And then the 24 here is 6-hour averages. So you can have 6,000 values, which means you have 1500 days. Okay. So is that clear? So heartbeat, step, this value, the X file, XFF, where's the R? This one, X file factor. So sometimes you get values that are unknown. So the X file factor basically tells you what is the allowed XFF value or unknown values out of your the data that's collected, so that it is still able to consolidate it. So this one is 0.5. So half of them can be unknown. So as long as you have at least 50% off, you can still have a consolidated value. All right? Is that clear? I know it's a bit too heavy. So if you look at, you'll have to double check, because you have a lot of arguments added for the RA and also for the DS. So just make sure that you do understand what these values are and what they are used for. Now for this one, what we were trying to do is maybe come up with a graph. So we want to have some data in it. So this part is actually just a way to have some random values added into your RD file. So it's not technically important. Usually we use information that is coming from SNMP, right? Or any way that we're pulling data. But this one essentially just to have some data into our RD so that we can show something in the graph. But to create a graph, we use the RD tool graph command, and then put that into generate a PNG file. So again, once you're running, let's say LibreNMS or SmokePing, you will usually have a folder with lots of like images.png, which is this. So that is when like your RD tool is creating those graphs for posting so that it can be shown in the web UI. All right. So that's a very quick example on how it's done. So that means actually using this tool, you can customize what your graph will look like. What is the interval? What color will be used here? What these values are for? So what will show in the right side there? So things like that you should be able to see. So there are a few tools that are available online if you want to just give it a try. So you can create them quite quickly using these tools. All right, now we have a few applications that are commonly using RD tool, and that is SmokePing, Nagios, LibreNMS, some of the common tools that we are using on our system for a very, very long time now, I suppose, for a lot of people. So what we're going to do now, I think we should have time, is to go through the labs. So if you are available, if you have your laptops with you, I think most of you do, please go to the link we have from the Academy event page. Again, we should have the exercise link, which is this. Okay, so click on this one, NMM, SNMP, Libre NMS, and RD tool. So if you open that up on a new tab, it will show the virtual labs page, and the very top will be this particular virtual lab. Now you will need to be logged in to load or to launch the lab. So this one, you should see a link, a button to click launch lab. Now when you do that, it will ask you whether you want to continue to launch it, and just click yes. If that, yep, that worked. And it loads it. Usually it loads it in a new window. So just please make sure that you don't have, that you're allowing it. Usually with Chrome particularly, they will not allow pop-ups. So just make sure to allow it first before continuing. I think I'll need to close one because it opened two. So here it is. It should be fairly quick to load because it's a small topology. So if you can please all try this, I think that will be great. How many of you need help to log in or to load the lab? How many of you are following and doing the labs? Yes, please commit to the labs, please. Okay, so we will have something like this. So we can all do it together. Oh, wait, I have two running now. Give me 1 second. I think I may need to close it the same. Yeah. All right. So how many of you have labs that have loaded and looks like this? Okay, so anyone else needs help to log in? Go to, let me explain from there. That's the thing, you're the second or third person to ask, but basically you need to go to academy.apnic.net. Okay, for those who missed, earlier I explained where to get the materials. It's actually on the APNIC Academy. So what you do is go to academy.apnic.net. And then once it loads, you will find the event just somewhere here on top on the upcoming training events. This one here is what we are after. Click on that one. And once you are on this page, you actually have two tabs, the course overview and the course materials. In the course materials page, you can go down. You have day one. So this is the links to the presentation. And what we are after is this exercise. So click on this, and that will load the lab. Mine is already loaded, so I don't need to do it again. But that will essentially load the virtual labs page for you like this. and then you have to click Launch Lab. For those of you who already have access or have used the virtual lab before, and if you have any running virtual lab and that is saved, you will need to close them or end the virtual lab. We can only run one virtual lab at a single time. So please end all other virtual labs that are running and then launch this one. Does anyone else need help here? Thinking about. I think we will need to pause for break very soon, or maybe now already. So what I suggest is for you guys, if you want to go have some food, is please feel free to go and grab something. Just make sure that you load the lab or save it if you need to go for a long time. So just make sure that you can launch the lab for now. Is anyone else still having issues? Is everybody on a page that looks like this? Yes, yes, yes. On the way. All right. While you guys are doing that, I do have a couple of giveaways. Maybe I'll just leave it in the middle. Help take them. We have more in the booth, so if this is enough, we can always grab something at the booth. But for now, I just have these. So maybe I'll ask some questions a bit later for these, but for the pens, please feel free to grab them. All right, everybody in the lab. We're not supposed to break yet, right? Are we supposed to break? Yeah, but we started late. Oh. Yeah, 20 minutes late. So I'm not sure whether it's ready. Okay, so again, what we're gonna do now is maybe just make sure that you can launch the lab. And at this stage, they're just checking whether the tea break is ready. If you can have a quick break, 15 minutes, and then come back, and then we will continue with the demo. Thank you.